This video lesson will focus on expected value. Expected value is a long-run average. It is used for calculating long-term gains or losses for places like casinos, lotteries, for insurance companies, investment firms, and more. It is really important to keep in mind it is a long-run average. So on any given play of the game or any given event that an insurance company deals with, there will be an outcome. But the whole thing is that in the long run, whether it's a casino, whether it's a lottery, an insurance company, an investment firm, or whatever, their goal is for them to make money. On our end, it's our goal to make money, especially if we're dealing with like a casino or a lottery. And so we're going to see how expected value is calculated and how those casinos and lotteries in particular ensure that they are winning more than you are. So expected value is calculated fairly simply, actually. What you do is you find the probability of every outcome that could take place in a given scenario, and then you multiply by the outcome itself. Okay, so what you're actually going to gain or lose, and then you find the sum of all of those products. So for example, outcome number one might be that you're playing a game and you win $3. So outcome number one would be $3. And the probability that you win $3 might be, say, 1/4. And then you would add the probability of the next outcome. Maybe the next outcome is you lose $1. So x2 would be -1. And then you multiply by the probability you would lose $1. Maybe that's 1/2. And then you keep going with all the different outcomes that could happen. Again, typically that you're going to gain or lose money. And then you add up all of those products together, and that gives you the expected value. So let's try it in a fairly simple and straightforward example. So a card game is played by drawing a single card from a standard deck. It costs $3 to play this game. If we draw a face card, we're going to win $5, and otherwise we're going to end up losing our money. What is the expected value of this game to the player? So we'll begin by figuring out the different things that could happen. Okay, so first of all, if you draw a face card, you win $5. So if we draw a face card, the probability of doing so is 12 out of, sorry, I thought that was the pen, that was my highlighter, is 12 out of 52. We have a 12 out of 52 chance of drawing a face card from a deck. Now, it says we win $5, but remember, we paid $3 to play this game. And so ultimately, we end up coming out $2 ahead. Okay, we paid $3. They gave us $5. We now have $2 more than we had before we played the game. Okay, the other thing that could happen is we'll lose our money. So if anything other than a face card comes up, which there are 40 out of 52 cards that are not face cards, we will end up losing our $3. Okay, we're going to just basically give them our money. So then those are the only two outcomes. We win or we lose. Okay, take into account the fact that we did pay to play the game, and then multiplying these values and then adding or subtracting, since we have a negative value, we will determine that the expected value of this game is -1.85. Okay, and since this is a dollar game, like we're paying money to play, what this means is that as a player, you are expected to lose or come out behind by $1.85 on average if you were to play this game over and over and over. So do keep in mind, expected value is a long-term average. On any single play of the game, you will either win $2 or lose $3. But if you were to play this game over and over, or let's say a casino was going to feature this super exciting game at their casino, In the long run, players would lose $1.85 on average, which means the casino is gaining $1.85 on average for every person they can get to sit down and play this game. Let's take a look at another game scenario. So the game is played by rolling 2 dice. It costs $5 to play. If a sum of 7 is rolled, we're going to win $5. If a sum of 2 or 12 is rolled, we're going to win $15. And otherwise, we're going to lose our money. Find the expected value of this particular game. So here, notice there are 3 separate outcomes, okay? We could roll a 7, and that means that we will win $5. So if we roll a sum of 7, we're going to win $5. Well, we paid $5 to play this game. So if we win $5, essentially we have broken even. We haven't actually made any money. And the number of ways that we can roll a sum of 7 is found right here on this diagonal. So there are 6 out of 36 ways that that can happen. Okay, we might roll a 2 or a 12, again, a sum of 2 or 12. If that's the case, excuse me, we're going to win $15. Well, again, we paid $5 to play this game. If we win $15, we come out $10 ahead, and there are 1, 2 out of 36 ways to roll a sum of 2 or 12. Or we could roll anything else, okay? So anything else, let's see, we've taken care of 6 plus 2, 8 of the outcomes. So there are 28 outcomes that are losing outcomes. And if that happens, we're going to lose our money. So we're going to lose the $5 that we paid to play this game. So multiplying and adding these up, obviously the first term there is 0. And then continuing on, so multiplying 10 by 2 over 36, and then adding -5 times 28 over 36, we get a -$3.33. In other words, if you decide to play this dice game, you will lose on average $3.33 over the long haul. In other words, if you come out ahead at any point, you should take your money and walk away because the odds are not in your favor. All right, and let's look at one more example. And this is a pretty simple way to look at how insurance companies make sure that they are collecting enough money so that when there are losses, they can pay out. But we're going to start here again, just with a very simple way of calculating an expected value regarding, in this case, a home that is a total loss in a fire. So if the probability of having a total loss in a fire is 0.0003, and we want to insure a $150,000 home against a total loss due to a fire, the insurance company has decided to charge a $75 premium or a fee. That's what you would pay for insurance. Now, in real life, insurance is quite complex. You're not just paying to protect yourself against the total loss of a fire. You're protecting yourself against partial loss from fire, from flooding, from hail damage, storm damage, tornadoes, water leaks, whatever it happens to be. So there's a lot more involved, but this would be a small example of one piece, perhaps, of your insurance. So we're going to calculate what the expected value is to the insurance company. So we're going to take a perspective that is, we are the insurance company, and we're going to go from there, okay? So what could happen in terms of the insurance company? Well, there could be a total loss of the home, okay? There could be a total loss. And in that case, the insurance company has to pay their customer the value of the policy, or $150,000, so that they can replace the home, okay? But the insurance company did collect $75. So they got $75, well, for that part of the insurance. but then they pay out $150,000, that means that if the home is a total loss, the insurance company actually loses $149,925. So that's $75 minus the $150,000 payout. The probability there is a total loss is 0.0003. Okay, so pretty small chance that that's going to happen. Otherwise, what could happen is we're going to look at it again as there's no loss. We're greatly simplifying this process. But if there's no loss, the insurance company takes your $75 and they get to keep it. Well, other than they'll probably end up paying it to someone else whose house catches on fire, but they get to, that's profit for them, okay? If there's no loss for you, in terms of you, that is profit for them. And if there is a 0.0003 chance that you have a total loss, then there would be a 1 minus 0.0003, that's the complement, chance that there is no loss. And so that is 0.9997, okay? Again, multiplying these together, we end up with, doing a quick calculation here, we end up with $30 as the outcome. And so what that would mean is that the insurance company is averaging $30 in profit for every policy like this one that they would issue. So again, as you are calculating expected value, think of every outcome that could happen. Always take into account whether or not you are gaining or losing. Adjust the sign of the number appropriately. Don't forget that there's money that is put down initially, in most cases, to play the game or to purchase insurance, whatever that happens to be, and multiply each one of those wins and losses, the amount won or lost, the amount gained or lost, by the probability that you would gain or lose that much money. Multiply them all together, add them up, and you will get the expected value, the long-term average gain or loss whenever you repeat this scenario over and over and over again.